Hello students, today we're going to be learning about 45, 45, 90 special right triangles. Let's begin with the warm-up about 30, 60, 90 triangles. Okay, looking at number 1, we are given the long leg here. It'd be really helpful at this point to just be in the habit of always drawing the mini triangle no matter what you're doing. This will really help you memorize the relationships and also get comfortable using proportions. So I drew the mini triangle just how both of these are sitting, and the mini triangle has a 1 on the short leg, 2 on the hypotenuse since it's double the short leg, and square root 3 on the long leg. So when I look at number 1, I'm given the long leg as 2 square root 3. If I can see the connection to the mini triangle, I can know right away that x just has to be 2, because the long leg is always the short leg times square root 3, just like you see in this example. So I don't have to do any work as long as I understand that pattern. If with the hypotenuse is just double the short leg, so it's just 4. Again, it's really important at this point that we're really understanding the relationships within the 30, 60, 90 triangle. So I'm done on number 1, and those are my final side lengths. Number 2. Number 2, it doesn't seem like I can take any shortcuts because I'm given the long leg, and it doesn't have a square root 3 next to it. So it looks like I need to just set up the proportions here. So I'm given a 2, so let me put the 2 on top and the square root 3 on bottom, since these two sides, so let me make these blue. So 2 and square root 3 correspond to the same side. And also let's use x, so we'll put x on top and 1 on the bottom of this one. Okay, so cross multiply, so we get x square root 3 equals 2 times 1 is 2. Divide by square root 3 on both sides. We get x equals 2 over the square root of 3. Rationalize the denominator. We can't have that on the bottom. So we get 2 square root 3 over 3. So that means x is 2 square root 3 over 3. And our hypotenuse is double that, so double that would just be 4 square root 3 over 3. Alright, so at the end of this lesson, you should be able to find the missing side of 45, 45, 90 special right triangle given either of the legs. So in this case, let me change this, given the hypotenuse or the leg. Notice I'm taking out the word short because when we have a 45, 45, 90 triangle, the legs are exactly the same. One is not any longer than the other ones because the base angles are the same. So actually what we have here, and make sure you're writing this into your notes, is an isosceles triangle. This is really, really important because we know that for an isosceles triangle that the legs are the same measurement. So we can put these tick marks here indicating that these two legs are the same. So let's see how that looks on an example. So in these first two problems, notice that my title up here says, what if we are given one of the legs? So in this case, we're given 2. Well, since it's 45, 45, 90, that means that y also has to be 2, because it's an isosceles triangle. That makes our life really easy because now we can just use the Pythagorean theorem. So we have 2 squared plus 2 squared equals x squared, the hypotenuse. So that's 4 plus 4 equals x squared. Simplifying, we get 4 plus 4 is 8 equals x squared. We'll square root both sides, so we get x equals the square root of 8. And when we break down 8, 8 is 4 times 2, and then that's 2 times 2. So this ends up simplifying to 2 square root 2. So let me fill that in as our hypotenuse. Okay, looking at number 2, so again we're given a leg, which is 4. If we're given this leg of 4, we know that y also has to be 4 because it's an isosceles triangle. So same as before, we just need to apply the Pythagorean theorem. 4 squared plus 4 squared equals x squared. We get 16 plus 16 equals x squared. And 16 plus 16 is 32. And now we take the square root of both sides. So we get x equals the square root of 32. Simplifying that using the factor tree, so 32 breaks down to 4 times 8, and 8 breaks down to 4 times 2. Notice that once I see a pair of 4s, I stop right there. I could break it down into 2 times 2 more, but that really just creates more work for ourselves in this case. So if you recognize that you already have a pair, just stop your factor tree there. So our final answer ends up being 4 square root 2 as the hypotenuse. So pay close attention, so you may want to pause and give yourself a little bit of time to think. What pattern do you see in these special 45, 45, 90 degree triangles? Well, it's obvious that the legs are the same, so whatever one side is, the other side has to be the same thing. And both of these have a square root 2 as the hypotenuse. It's just the leg times square root 2 in both of these. So look at the hypotenuse here, it's just 4, the leg times the square root of 2. Same with number 1, it's the leg times the square root of 2. So let's take a minute and write our mini triangle, or the generalization for this. So when we're given a 45, 45, 90 triangle, it's isosceles, so if this side is 1, this side is 1. I use the easiest numbers to create the mini triangle. That means that this side, the hypotenuse, must be the square root of 2. If you don't believe me on the square root of 2, you can plug into the Pythagorean theorem and check that. It'll always end up being this pattern. If you don't like using numbers, you can always use variables. So if I was given x here, then this leg has to be x, which means the hypotenuse is just x square root 2. Again, this page is very, very important. Make sure that this is written in your notes with stars and boxes all around it. So we can do problems when they give us the leg. So let's see if we can do a problem when we're given the hypotenuse. So looking at this one, we're given 5 here. So there's a couple ways to do it. One way would be just to recognize that these must be the same. So if this is x, we should really change this y to an x because they're really the exact same thing since it's an isosceles triangle. So from here, and there's a couple of different ways when they give you the hypotenuse. I'm going to do this 2 different ways just to show you guys a few methods. So I'm going to call this, let's say, strategy 1. And then we'll show a different way, which will be strategy 2 in a minute. So for strategy 1, you just use the Pythagorean theorem. There's nothing new here. Both of these are the same variable, so we have x squared plus x squared equals 5 squared. X squared plus x squared is 2x squared, and 5 squared is 25. I need to divide by 2 on both sides, so I get x squared equals 25 divided by 2. So from here, we can take the square root of both sides, and we end up getting x equals the square root of 25 divided by 2. We can leave it like this for now. If you do need to simplify further, you can. This would simplify, so you'd just take the square root of the top and the square root of the bottom. So the square root of 25 is 5. The square root of 2, we don't know. We can just leave it as the square root of 2. But then rationalizing the denominator, we need to multiply by the square root of 2 over the square root of 2. So this becomes 5 square root 2 over 2. So that would be our final answer for x. And again, both of these sides are the same. So that's one way we can do it, simply just plugging into the Pythagorean theorem. If you'd rather use a different strategy, the mini triangle can always work on this one. And really the mini triangle would work on any of the problems. So let's go ahead and do this one more time. And we were given 5 here, and an x and a y. So let's draw the mini triangle right next to it. And the mini triangle has 1, 1, and square root 2. So now that we have a mini triangle, we could use proportions or similarity to solve. So when we write this, we can just do 5 over square root 2. Those are corresponding hypotenuse right there. And then we can do x over 1. So when we cross multiply, we get x square root 2 equals 5. And we can divide by square root 2 on both sides. And we get x equals 5 divided by the square root of 2. And we need to get rid of that square root of 2 on the bottom since it's not simplified. And finally, simplifying, we get 5 square root 2 over 2. So that is x. And that's also y, since this triangle is isosceles. Different strategies. One uses the Pythagorean theorem, one uses the mini triangle and cross multiplying, and you get the same answer. So they're both great ways to do the problem. Your preference. Now here's 2 problems for you to try, and so give those a shot. I'll see you tomorrow.